Hello, welcome to Slater PE's Mechanical Engineering PE exam review videos. This is Mass Balances 2 of the Energy and Power Systems module. We recommend watching these videos in order, so if you have not seen Mass Balances 1, you should consider going back and doing that. Otherwise, let's get started. Alright, so what we'll do in Mass Balances 2 is continue our discussion on volume flow rate, flow velocity, and mass flow rate. We are just going to do one example emphasizing this relationship just to further solidify that topic. Okay, so here's the problem statement. At this point, you are free to pause the video and attempt to solve the problem on your own. If not, just let the playback continue and we'll solve it together here in real time. Okay, so what we have is a garden hose, and they're filling a bucket with a garden hose. And there's some other information here. So, we make a little sketch of the information given and write the equations that we might possibly use here. So one of the things to point out here is this internal diameter of the hose, it's really not necessary for the problem. That's what we call superfluous information. And the problems in the PE exam are full of those. There's a lot of information in the problem statement that you won't need. So we just want to get you used to that. Okay, so essentially, if you've read the problem statement, what we need is to figure out the volume flow rate of water coming out of the nozzle to figure out how long it'll take to accumulate a volume of 10 gallons. Okay, so it looks like the equation that we're going to use is this one, right? Because we really need the volume flow rate, right, in gallons per minute to figure out how long it'll take to accumulate a volume of 10 gallons. So it's the area times the velocity. So since we're doing the velocity at the tip of the nozzle, that's the area that we have to use. So we're just going to write pi divided by 4, 0.3 inches. That's the diameter at the nozzle tip, and then 50 feet per second. Okay. So now we just have to be careful with the unit. So we're going to use the conversion factor, or the unit conversion factor. 1 foot is 12 inches, right? And we're doing that so that, and squared, right? So we get the inches squared turned into feet squared. So now with this we have the volume flow rate in cubic feet per second. So the other one we would need would be times 7.48 gallons for every foot. Okay, so in this way we would get the volume flow rate in gallon per second, and that would be 0.1836 gallons per second. Okay. Another step we could take here is to express it in gallons per minute. So we use another conversion factor here, 60 seconds for 1 minute. And in this way we get approximately 11 gallons per minute. Okay, so if we have a volume flow rate, V dot, right, then the time interval delta t, if you multiply that times that rate of volume, right, of volume flow rate, you get a total accumulated volume, right? So if that volume is 10 gallons, the volume of the bucket, and you divide that by the rate, then you're going to get the time required to reach that value. So in this case, our volume is 10 gallons, and our rate is 11 gallons per minute. So we get a time interval of about 0.9 minutes. So in this case, the answer is B. Notice that in seconds, 0.9 minutes, you can figure that out, it's 55. So if you kind of glossed over this part here where the time is required to be in minutes, you might get your answer in seconds and choose D, which would be technically wrong because they are specifically asking it for minutes, right? So just a heads up about this kind of deal. Okay, that sums up Mass Balances 2. So now we're ready to look at Mass Balances 3, where we'll actually derive the mass balance equation and use it to solve some more examples.